Okay, today we're going to talk about Chapter 7, Section 6, Growth and Decay. Exponential growth function. Keep in mind yesterday growth functions, remember, started really small and got really large. Okay, this is the equation for an exponential growth function. A is the initial amount, R is the rate of change, T is the time. Okay, and Y is the final amount after the time. So a problem. Okay, the prize for the radio station contest begins with a $100 gift card. Once a day, a name is announced. The person has 15 minutes to call her. The prize increases by 2.5% for the next day. We're going to write an equation, okay, to represent the amount of the gift card in dollars after T days of no winners. So this T days thing, okay, means we're going to leave T for time. We're not going to put in a time. Okay, so we have Y equals A times 1 plus R to the T power. Okay, for this, with leaving T as T, we need to know what A is, and we need to know what R is. Okay, A, right here, initial amount starts at $100. So we got $100 for A. R, right here. Okay, now we need to put it in decimal form, not in percent form. Okay, so 2.5% turns into 0.025 as a decimal. Okay, so that's what we're actually going to plug in. So then our equation is going to be Y equals 100 times 1 plus 0.025 to the T. And we can simplify this down to get 100 times 1.025 just by adding those things to the T. So this is the equation with T as our time still. Okay, now we go down here to the next part. Okay, this is where we're actually going to put a day in. How much will the gift card be worth if no one wins after 10 days? So now we're going to go take that equation we just made, 1.025, but now instead of to the T, okay, we're going to let T equal 10, so we're going to put 10 in here. Then we'll just put this in our calculator. And you can just type everything exactly like this in your calculator. For the exponent, you're going to have to use the caret key or the little arrow button. Okay, and you should get that this is $128.00. Now we want to round to 2 decimal places because I guess it'd actually be 0.01. Round to 2 decimal places because we're dealing with money. Okay, that's exponential growth. Next one we're going to look at is compound interest. Now, compound interest is interest earned or paid on an initial investment, and the interest is already earned. So in other words, we're not just paying on what we started with, but we're also paying on money on interest that we earned. Okay. A is the current amount. P, that's the principal. That's the amount we start with. Okay. Initial amount, that's the amount we start with for P. N is the number of times the interest is compounded each year. Okay, so if it says compounded, let's say quarterly, that's going to be N equals 4. Quarterly, there's 4 quarters in a year. Okay, so compounded quarterly is 4. If it says daily, right? How many days are in a year? 365, so it's going to be N equals 365. Monthly, okay, how many months are in a year? 12, so it'd be N equals 12. Okay, so the compounded part, that's where the N comes in. However many times it's compounded, that's what our N is going to equal. Okay, also the word compounded is what gives it away that you're going to use this equation. Okay, and then R again is the percent as a decimal. Okay, it's important that we do it as a decimal for R. Okay, so problem. Maria's parents invested $14,000 at 6% per year compounded monthly. How much money will there be in the account after 10 years? So we're going to use, because it says compounded, this is what we know to use the compounded. So it's going to be A equals P times 1 plus R over N to the NT. And we need to know what P is. We need to know what R is, and we need to know what N is and T is. Okay. P, initial amount, right there. That's P, so 14,000. Okay, R is the rate again, so it's 6%. Now remember, 6% as a decimal is 0.06, so that's the actual amount we're going to use. Okay, N, okay, it says compounded monthly. How many months are in a year? It's 12, so that gives us that N is going to equal 12 there. And then T, of course, is how long. It says 10 years here, so we're going to put 10 in for T. Plug all this stuff into our equation over here, so we get A equals 14,000, parentheses, 1 plus 0.06 over 12 to the 12 times 10. Okay. Now, what I recommend you do is go ahead and multiply the N and T up there, so we get A equals 14,000, 1 plus 0.06 over 12 to the 120. Okay. Now you can just put this in your calculator exactly like this. 14,000 parentheses 1 plus 0.06 divided by 12 parentheses, caret key 120. And the answer will be $25,471.55. So after 10 years, that's how much would be in her account. Okay, last thing, decay. Okay. The only difference between the decay and the growth functions is decay has a minus sign in it. Everything else is the exact same as growth, except for decay has a minus sign, not a plus sign. Okay, so the problem here. So we're going to use a fully inflated child's raft. If pool is losing, that would be decay. Okay, this one gives us decay here. Okay, so we're going to use the y equals a 1 minus r to the t. Okay, 6 points. So we need to know a and r. Okay, again, it says equation to represent the loss of air. So since we're writing an equation, t is just going to stay as t. Okay, so a, or 6.6 for the rate. Now remember, that's a percent. We need to change it to a decimal, so it's 0.066 as a decimal. And then the raft originally contained 4,500 cubic inches, so a is going to be 4,500. Okay, so we get y equals 4,500, parentheses 1 minus 0.066 to the t. So then when we simplify this, we get y equals 4,500 times 0.934 to the t. Okay, now we go down here. Now it says, okay, how much would be in the air or in the raft after 7 days? Okay, so then we're just going to go ahead and use this as t. So it's y equals 4,500, 0.934 to the 7. Again, you can just go ahead and put that in your calculator. And we should come up with the fact that there is 2,790 cubic inches of air in the tube. And that's really all we have. So we got decay, growth, and compounded interest today.